in the evening, at least CET time. So time to start. Many thanks for joining. Looking as well online if there is anybody watching, let's say, the show, the meeting from the Facebook page. So yes, many thanks for joining. Welcome to this already 12th edition of the Commodore User Europe meeting. I did not prepare this year like I did before the, let's say, the statistics of the year, but I think we have quite a nice audience that is growing every time. A certain amount of meetings behind us and a lot of videos on our YouTube channel. Of course, every time you do a presentation here, this is being recorded. Actually, I will record these as well today, and of course these are then available on our YouTube channel later on. So I have actually two small announcements. One is the same as last time. We have a Discord server, so the invitation that I had issued last time is not valid anymore. So I issued a new one. I will also put the link later on Facebook, but you can also either make a screenshot. I should have made a QR code now. I just realized that. Another thing is that normally we had another speaker on the agenda today. That's Simon Punt Be. He has made a super nice website, kind of collection of Mastertronic games and reviews of games, etc. But unfortunately, he was not able to join and present in person today. So I would say hello, Simon. I hope that we get you at another time. I have put here the link to the website. I hope it's the page is actually moving. I'm not sure. I will just switch and I will share again the entire screen this time. Share. Yes. It seems like there is some delay between what I see here. What are you guys seeing? The announcement page or still the first page?
I see the announcement page.
Okay.
Announcements, perfect. Discord, and so on.
Excellent. Thank you. Thank you for the confirmation. I think there is a small delay.
Not in presentation mode.
No. That's I know that. No, it's a PDF actually. I'm just switching. Okay, but then yes, of course, the agenda for today. A very exciting agenda, quite rich in technical topics. I would say that's a feedback I get very often now that our meetings are like because of the technical approach. So it's always good to hear some feedback, especially when it's positive. I think people are comparing and they say, okay, some meetings are only games, some meetings are only reviews of some release, but here we have a kind of versatile tech meeting. So today we'll start with a tool for building images for Amiga, and then we have an OS or an early OS for the Commodore 128. New game or remastered game on Commodore 64. Preprocessor for Oscar 64, and a new release, of GeckOS 2.1. And to close the CPM for the 6502, so CPM on the Commodore 64, that will be super nice. Can I just ask everyone to mute when it's not your time to talk, because that's making some let's say background noise. And I will stop sharing, because then our first speaker is Stefan. Stefan, you're already with us.
Yes.
Yeah, perfect. So you can, I don't know if you start by sharing something or not. Yes, just wait a second. I will start the recording then. called? Yes, and the floor is yours, Stefan.
Yeah, thanks for the invitation, and it's my first Commodore User Europe meeting I attend, so will be the first of many, I hope. So I'll be presenting today one of my pet projects. It's Amiga related because I'm a huge Amiga fan and I like to tinker with it. And it's DPaint.js. DPaint.js is a online image editor with a strong focus on Amiga file formats. It's open source and free, and it's one of the things I like to tinker with, and it will expand in the future. And I'm just presenting or talking about how I came to develop this tool, and what I think at least are some pretty cool features of it that you won't easily find anywhere else. So yeah, I first started with the Amiga a long time ago. This is my first Amiga. I still have it. It has the battle-proven scars, and I refuse to clean it because it should look like it has seen some tough times, and it really has. But and I've been well, drawing and painting all my life, and of course the Commodore Amiga was the device that brought everything into the digital age, which was a pretty huge eye-opener for me back at the time, and I guess I'm not the only one. Made a lasting impact, and I'm one of those people that started tinkering with the device, creating music, creating graphics, starting programming, and found it so addictive and fun that I ended up doing that for the rest of my life as my day job as well. So that's it all started with this machine. And back in the day when I was started pixeling, of course, the first one of the first things you bump into is Deluxe Paint, the paint program for the Amiga back at that time. And I guess I was like 15 or 16 years old, and I started pixeling the things that I found interesting at that time, which in my case wasn't cars, but the other thing that find 14 and 16-year-old interesting, which was mainly images like this. So these are made in Deluxe Paint back when I was very young. My handle was DKM, and I started doing sound and stuff like that. So that was one of the first things I did. Later on, I moved on to other topics as well. Kept on using a Deluxe Paint, so this is one of my other drawings. And well, you notice that most of my work has a solid color background, and that's just because it's a lot of work to create images like that, pixel by pixel. So I moved on, as most of people, to PCs and other stuff. But of course, the Amiga kept lingering, and in my day job, I was working in user interface design and stuff like that, and doing some development. And I thought, okay, let's do my user interface skills. Let's reapply them to the Amiga, and I started doing these icons and themes for the Amiga. This was one of the first one I did. It was one for the CD32. So I created the icons and stuff like that, and had very fun with it. And then I found that it's not that easy to go from modern software to actual Amiga files. So this is one of the other icon sets I did. It's for Coffin OS, which was originally it's for the Apollo Vampire accelerator card for the Amiga. And this was not made in DPaint because I had moved on. So this was actually made in Photoshop. So this is the Photoshop file for the Coffin OS icons I used. By the way, I still really like Photoshop, and mainly for this reason that there's still some people that are loving Amiga, because there's still some hints. If you put what would save as a copy, you actually can still select the IFF format, which is the native Amiga format, and when you click save, there's actually a mention of still Amiga in the latest version of Photoshop. Do you want to platform Amiga or Maya? By the way, this is just by name, because the IFF export doesn't work at all of Photoshop. So I don't know why it's there, but I love it that it's still there, even in the most recent version of Photoshop with all the AI tools. Somebody still loves Amiga there as well. But moving from modern files like Photoshop to icons proved to be pretty cumbersome. And being a software developer myself, what guys like us then do is we build solutions to handle a certain problem. So I started building an icon converter at first, which was actually the one of the first features that, well, the only feature that DPaint.js, we called that back at the time, supported. So it was mainly born as an internal tool to convert modern file formats to Amiga icons, which is a format that no other modern software still supports. So I took a deep dive into the file format and created a tool myself. And I wanted to have some pretty specific features to speed up my flow. For example, this is one of the icons that is in the Photoshop file, so the system icon, which is just a PNG stitched together, which works on OS4, but not on a classic OS3 and beyond and below. So I needed a way to convert it, and all the other tools that do automatic conversions, they weren't that great. For example, one of the features I really wanted to have is an instant preview of some icons. So this is an icon with two states, and you can just preview it instantly. And if you convert a PNG to a classic Amiga icon, you will lose the transparency, and you, of course, have to reduce the color. So I started adding features of reducing the colors, for example, to 16 colors, and then it automatically optimizes stuff, etc. And the item I missed most in other software was this slider, which basically sets what kind of semi-transparent pixels in your modern PNG should be translated to non-transparent pixels in a classic Amiga. So if you look at, for example, on the black background, you see it closely. There's now a white border because these pixels are still displayed here, and you can just adjust the slider like, okay, where does the transparency stop, converting semi-transparent pixels to non-transparent, and you can just still manually tweak some stuff until it looks okay in a 16 color mode on all the different types of backgrounds. So that was really the main reason why I started to create my own image program to do stuff like this, and to have a reasonable, nice flow of converting modern images to classic icons. For example, the super classic ones, the OS3 and 2, they use mostly the magical user interface color. So there are some options that you can just apply this, and then it will adapt to that color scheme, and you can just add some different dithering modes, so you can just fiddle with it until it looks okay enough to have as a classical icon. So this is, for example, an icon that then works on all Amigas, even the really old ones like the 1.3s, etc. And then if you save it, you have an option of, okay, what exactly do you want to save? It's an Amiga IFF image. Is it a classic icon for really old Amigas, or a color icon for more modern ones, or a PNG icon for the expanded or accelerated ones, etc. So I was happy with it. I created most of my icons with it. It didn't look like this because it was still very raw. But then I found I really like pixeling. So but again, my earlier work had mostly a solid color background just to save some time, and icons are really small. So, but then I thought, okay, I'm gonna do a bigger work, which is something I had an idea to participate in the old school graphic competition of revision of this year. And very eagerly, I started pixeling and painting in Deluxe Paint, and that was kind of a horrible experience because, of course, we are a bit spoiled with modern tools, and if you then go back to that old Deluxe Paint experience with only one undo, with no layers and stuff like that, um, you have to be a special kind of person to still enjoy that, and that person turned out to be not me because I didn't enjoy that much. So this is, by the way, the image I made for revision, which I started actually to do on the Amiga. So this is done on Deluxe Paint on the Amiga. But then I started adding details, and it was just a horrible, horrible experience. If you make a little mistake, then okay, it's clearly not a very modern tool. So then I moved back to Photoshop, the tool that I know. But then, of course, you start missing that pixel-specific feature set that Deluxe Paint on Amiga has that Photoshop doesn't have anymore. Because if you work in a fixed palette in Photoshop, the index colors, you lose stuff like layers and things like that. And so I thought, okay, again, I'm a software developer. Let's develop some software tools to fix my need in software. So this is another stage. So I started expanding my little image editor that I had created to do my icons. And one of the things I really missed in Photoshop, and I think mostly all modern tools, is that pixel perfect preview before you put the pixel. Also, this is the image. It's in 16 colors. So it has yeah, these 16 colors. And for example, one of the features I like most on Deluxe Paint is that if you preview it, you can have a dual pane with different zoom levels, and it has an instant pixel preview. And what I mean by that is, let's zoom to the eye so you can just have a better look. If I hover over this left pane, then you see the white pixel in preview as well in the zoomed in version, which is something that Deluxe Paint does, but no other modern software does anymore. And that's really important if you really like to deep dive and have a pixel perfect, that you can preview the pixel just in place before you actually click and put it. Oops. And put it actually in place. So things like that, stupid stuff that I found missing. And then I started just expanding and doing other stuff. For example, the ditter brushes. If you put, for example, I've selected white and this ditter brush, and then you can just start painting even with a large brush, but it will remain in this pixel pattern, which is kind of nice if you want to blend in two colors, etc. So I started adding feature after feature until I was pretty happy with it. So this image was mainly finished in DPaint.js, which I then kind of released because it was more or less ready enough. And so I added then Amiga specific features like loading and saving of all types of Amiga file formats like IFF images and ham images and whatnot. So it already could load and save all the icon formats. And now I expanded it with the image formats. And I added stuff, for example, you can directly open an ADF image, which is an Amiga disk image, for example. This one, and then you can directly open and edit the icons in it, or you can directly open and edit the images there are. This is a ham image, another one, a low-res image, etc. And save it back, so it will update the ADF image directly, which is kind of handy if you're working with Amiga-specific stuff and you want to directly test it on a real Amiga. You can directly save the ADF file on a USB stick and put it in your GoTech and load it in an Amiga, which really sped up the testing and the creation phase. So then DPaint.js was born. First initial version, and then I just kept on going. I still liked pixeling a lot, so I started doing some demo work. For example, this is one of the demos I did, which is Defunk, which was released at Nova in this year. Happy to say it won first place in the small size competition, because the target was 64 kilobyte, which is not a lot for a demo. So the challenge there was to actually create as good graphics as you could get in that small file size, which opened another can of worms. And that was one of the things that it was really handy to have created your own tools, because then you can start adding features that, well, nobody else has because nobody else needs it. And for example, one of the things was that it was quite amazing, for example, if you want to achieve a small file size, which is in this case a file that compresses optimal with the compression algorithm that was used for this demo. And it turns out that it really had a large impact on what order you had in your palette. And that's, of course, if you realize it, it makes perfect sense, because oops, it's too much noise. Yeah. So if you start doing a pixel work, so this is let's say a pixel work, and you start adding pixels, of course, you notice probably that the Amiga is a bit plane format, so it actually stores each bit map, which is a map of bits, separately in a file. And if you have a lot of colors, then these get splitted in different bit planes, and they get saved next to each other in the file. And so the file then looked like this, which doesn't compress as good. So these are all the zeros and ones. This doesn't compress good, because you really want to have something like this instead of something like this in a binary file view, which is makes perfect sense, of course. But yeah, the human brain is not mapped to translate this target image to something that you can actually use in colors. So then, and of course, the computer is pretty efficient in doing that. So I started adding really weird features that I had to use. For example, if you edit the palette, that you can choose to sort it in a file size optimal way, and then it, of course, I have to load the correct palette. Yeah. And if you then sort it, it kind of brute forces it and says, okay, if you take this palette order, then your file size will be like 2 kilobytes smaller, which is a huge difference in if you're talking about 64 kilobyte and other stuff like that. Running a bit over time, so I'm gonna wrap up. Other stuff I added was color cycling, which is a pretty cool feature of oops. That was also used in the demo, specifically made for that. So of course, this is a technique often used by Amiga formats to because changing a color in Amiga doesn't use CPU cycles, and in this case, I needed a CPU-friendly waiting screen because of the other effect in the demo, which is a very cool ham tunnel that Gigabyte, that's the coder of the demo, did. And it needed some pre-calculation time, which doesn't use CPU cycles, so that's why this screen is in front of it with the color cycling mode. And then it was really handy to be able to create your own files, because then you still have all the stuff like the layering and still be able to use color cycling, which is kind of handy if you want to create stuff like that. So that's the current stage. Currently, there's one feature missing, of course, before I can really call it Deluxe Paint clone. Well, it's not really a clone, but really a modern reinvention. I kind of hijacked the DPaint name, which is, of course, animation, which is the feature I'm currently working on now. Still a bit work of progress, but so it actually already supports the animation files of the Amiga, which is the anim file. So this is a famous one. I've done a lot of the game Space Age, so that you can. This is an animation that is in the Amiga file format, and it's work in progress. So there's not much user interface yet, but the loading and saving is already kind of working. So you have all the frames here, and you can just play them in a series. And the other pixel-based image format, which is still used, of course, today, is GIF or GIF. So that's also supported. That's wrong image. That's another image I did for another demo. It was this. So yeah. So that's just a GIF file. So the loading and saving of GIF and anim is already more or less working. Still some bug left to squash. Which also means I have now a tool that is pretty good at converting anim files to GIF and GIF to anim files and vice versa, which is also something that I guess not a lot of tools do. Yeah, so that's the current state, still work in progress. Open source, so if you are interested in the source, it's just on GitHub. And to close, one final Commodore Amiga to circle back is to still hint at the legacy where all this is coming from. There is a preview in Deluxe Paint, which actually spins up a embedded Amiga emulator. And so this auto converts your image to an IFF file. And then it loads the Amiga version, DPaint 2, where, my journey at least started. And it loads that image into Deluxe Paint 2, so the Amiga version. So there's still this, don't know if it's useful, but it's just a little gimmick, hint, or respecting your legacy, I guess it's called. So yeah, really one of my pet projects, having a lot of fun with it, and can't wait to release the animation part. So
that's great. Many thanks, Stefan. Maybe we can kick off the questions, but I will start then with some, because now the tool is actually online.
Yeah.
we have seen that you have this multi-layer. How does it work if you start? Do you have an experience with very heavy multi-layered images? Do you get? Then I suppose you have some limitation then, of course, of the
Yeah. Well,
the memory
of
of the
course,
computer. But
yeah.
what about the browser? Do you have any recommended browser or any special settings? Or
Well, it works on any modern browser, and well, I kind of like web applications because I use all kind of devices, just whatever fits the need, and online tools are just always there. But you're quite right; it's very useful for small scale pixel work like icons and Amiga specific graphics. But it's very true that if you load a huge image file, the browser is surprisingly efficient, so it still can load it. What's currently still difficult because it's just not optimized is the color reduction setting. So don't know if I have a large image here. Let's take the largest one, which is a pretty big. How big is it? Yeah, 1,000 something by 1,000 something. It's not that big, but well, file size is no problem, and you can still use all the layers and copy stuff and etc. etc. It's just that the color reduction is pretty slow currently. So there are some limitations, but it's actually quite useful also for doing modern, huge work. So yeah, but it works. Even I use it mostly on my iPad actually, so it works quite nice.
so you don't foresee any local version to be downloaded and installed for some specific I don't know, functionalities? No.
Nope,
Okay.
I really am a web guy, so
Yeah.
but
No,
I have people that have just forked the repository and build it into an Electron application. So they just wrap the browser around it and just put it as a desktop application. The step I will at some point take is move some parts like the really compute intensive parts to WebAssembly, which will make it much faster. And but let's just keep the feature set, or make the feature set complete first, make sure that everything works, and then we'll start optimizing the hell out of it.
Okay. Thank you. I don't see any questions in the chat. If any attendee has some question, please unmute yourself and you can ask the question. I will check on the Facebook page, but I don't see any questions there. Anybody? Questions for Stefan? Just unmute you. No.
Okay.
If not, then many thanks again, Stefan. I will stop the recording. And thanks again. And then I will invite, I think the next speaker is Bart with it's more or less an OS, Bart.
It's more or less it.
More or less an OS. You will talk about this. Let me just start the record. Are you ready to share something? Or?
Yes, I'm ready.
Okay, let me just start the recording then.
Just a reminder that I am not using Zoom to share, but just the camera. So you have to pin me, so it keeps me on top. Okay. Let's go. Multitasking on a Commodore 128. So I'm going to start a bit with an introduction about multitasking. I am going to keep that very short, but I do need to tell a few things about what makes for a multitasking system and what the problems are on the 6502 CPU, because there aren't that many multitasking systems on the 6502. However, there is a very old one going back to the 1970s, and it comes from a famous company, Commodore. I will get to that. So this is a short agenda of what I am going to tell. So a little bit of history, a bit about my operating system. I'm going to show a little bit from my operating system, and I have some frequently asked questions because people are asking a lot about this already. So the multitasking basics that I need to explain. First thing is we have a single CPU on a Commodore 64, Commodore 128, Amiga, doesn't matter. It all works basically the same. What you have to do is you have to divide the CPU time among the tasks that you want to run. And the easy way to do that is to have an interrupt every so often, and that interrupt does something that is called a context switch, and that context switch says like, okay, I have the next task, that is this, and I'm going to schedule that, and I'm going to leave it for a little while so it can run, and then I'm going to interrupt it, look for the next task to run, and so on. So that is how CPU time is divided among tasks. The second thing is we have memory, and memory on a modern computer is, well, it is virtual, and that makes a lot of things easy. We can set up an address space for each task that we want to run, and we can make it such that it only sees its own things, it only sees a kernel that it can call to, and it doesn't see any other tasks unless they want to share something. This is something that those who have a traditional Amiga, 68000 based Amiga, know that is not really supported on a 68000. It is certainly not supported on the 6502. And on a 6502, we have a very specific problem with it, and that is the stack. And why is this a problem? Well, on the 6502, you have a stack of 256 bytes, and normally you can't really change that. It is there, and well, it's the only thing that is there. So you can't have normally on a 6502 a separate stack for each task, and that is what you really would want because of the size, but also because you basically use the stack to an interrupt uses the stack to store some information, and it would be ideal if you can then assign a different stack, pull information from there, and use that to start or to run the next task that you have to run. On normal 6502, this is not possible, and this is the nice thing about the Commodore 128. It has a memory management unit which makes this possible, and that is also how this got started. Basically, I wrote a multitasking operating system for the 64 about 30 years ago. That was a proof of concept, never got anywhere beyond it because it's extremely inefficient. It can be done, it can work, but yeah, you have to copy a lot of data around to make it work, basically. And there are systems that do this, but there is a different solution for it. That is what Commodore used. We will get to that. But anyway, the Commodore 128 makes it easy to have a different stack for each task. And that is really what makes it possible to implement an efficient multitasking operating system on this. The next important thing to know about in a multitasking environment is devices. And the problem is very simple. you have, for example, a disk device, and you can't have two tasks trying to talk to the disk at the same time, because they may do conflicting things. They may try to send the head to the first track or to the last track, and they will interfere with each other. So you have to do something about that. And the last thing that I need to explain is tasks, processes, and threads. Normally, when you talk about a multitasking system from an end user point of view, you just say, like, I want to start a program, and the program is a task because I'm doing things in it, and I don't care how that really works. From a user point of view, you just see a task that you can run or a program that you can run. Underlying, there are a few things happening. On a very simple multitasking system, you just have processes, and that's it. On a slightly more advanced system, you have processes, and each process has a number of threads. And what is the difference? Well, we will get to that. So going back to the CPU, the time that a process or a thread actually can run is called the time slice, and it's a limited amount of time, and after that it will get interrupted. And that is why interrupts are very important in a multitasking system. Another thing that is important when looking at the CPU is ensuring that the right task gets to run. So you have to somehow assign priorities to tasks. So looking a little bit more at processes and threads, a process is really just something administrative. It is a container that contains resources, and resources can be memory that is assigned to the process. It can be one or more threads that actually get CPU time. And an interesting detail of that is that when you start a program or a task on a multitasking operating system, it can internally multitask again. So you often see that in modern systems when the user interface and some background process that is doing, for example, file copying or calculations or so on, those two things happen at the same time for the end user at least. And normally that is implemented by putting both in the same process and creating two threads. One handles the user interface and one handles whatever needs to happen else, the calculations or whatever. If you look at memory, I already mentioned that 6502 has no real concept of virtual memory. But it is important to understand that there can be private memory that is for a specific process or a specific thread only, and you can have memory that's shared between processes. Memory that is only used by a specific thread is called thread local storage. So it is only for that specific thread, and it shouldn't be shared with anything else. Another thing is that each thread needs its own private stack. Now, those two things are possible on a Commodore 128. They are not possible, basically, on any other 6502 machine. And again, that is what inspired me to delve into this operating system idea. Devices, you could imagine having a private device that is only for that one thread. You can also have shared devices like these devices that need to be shared between different tasks that are running. And for that, you need something called arbitration. You need a kernel, and the kernel needs to say, like, you get access to it now, and something else has to wait. So if we look at the history of multitasking on 6502 CPUs, well, one thing we basically all know, and that is having some music play while something else is happening. And the way that works, those who write 6502 code or things for the C64, C128 know that you have an interrupt and you let the interrupt call some music routine, and then it finishes doing a little bit of work and it returns to whatever other program is running. That is a very primitive form of multitasking. I wouldn't really call it multitasking, but it gives the impression, at least. The next thing on the list is the 15XX drives. And those are a really interesting story. I'm not going to delve too deep into that. But something to know is that the 1541, for example, the firmware on it, is actually a modified version of the firmware of much older drives. And those older drives had 2 CPUs. Yeah, Commodore made multi-processor systems in the 1970s. 1541 only has 1 CPU, and it needs to run the code that was originally running on 2 CPUs. So what it really does is it switches between what was running on the first CPU, and then it switches to what is running on the second CPU. One handles basically the drive mechanics and so on. The other one handles all the communications. And it switches back and forth between those two. And this really works like a very, very primitive multitasker with actually 2 tasks. Both tasks have their own stack. And how does it do that? Well, it really splits the system stack in 2 stacks of 128 bytes. And yeah, that is enough for a 1541. You could actually take that a step further and create 4 processes and give each 64 bytes, but you can't take it much further than that because, well, 64 bytes is not that much stack, and call a number of subroutines and get an interrupt and your stack is full, and that is a bit of a problem. Then you start overwriting the stack of another process. So it works, but very limited. Then at some point, don't know exactly how long ago, somewhere 20 years ago, 15 years ago, or thereabout, someone made something called Lunix, which is a Linux-like system for 6502. And this is portable to the 64, to the 128. It's really cool. It is very, very functional, amazingly so. But it is very inefficient because it needs a big stack. And how does it do that? Well, it simply copies the stack to a piece of free memory when the next task has to run, and then it copies the stack for that task on the place where it needs to be. And that means a lot of copying of data, and that is expensive and slow. So really cool, really, really functional, and really inefficient. And that brings me to my own project, OS 128, which is a temporary name, I think, not sure. At least it is the name I'm currently using, and I solved this in an entirely different way, which is really Commodore 128 specific. So going a little bit into OS 128, you have a few components that are important. One is the scheduler, and the scheduler determines which task can run at which moment. It uses a fixed length, time slice length for each task. That is at this moment, let's see, 6401 megahertz cycles, but it runs at 2 megahertz, so say 128,000 cycles. And after that, an interrupt occurs and the next task will run, and that is based on the priorities of tasks. Now, there are 4 priorities. One is time critical, one is high priority, one is normal priority, and one is low priority. And each priority has its own run queue, and those only make things more efficient because I only have to look at the critical queue to see if I have to do anything. I don't have to search all tasks to see if there is anyone critical, and so on. When there's nothing critical to run, it goes to the high priority and so on. There is something funny happening there, something I stole from another operating system called OS2. When there is no critical, when there is a critical task to run, it won't get to running a high priority or so on task. However, it will still look at those queues, and it will pick the first item from each queue and move it up one queue. But only if that queue didn't get time during a time slice. And what this guarantees is that every task will at least get some time every so often, even if there are a lot of critical tasks. And that is that brings us to the next point, preemptive behavior. One of my goals with this was make a system that is really responsive, no matter what you do. And that means also during I/O, it must be really responsive. Also, when there are lots and lots of tasks running, it must remain responsive. That was a very important goal for me. Now, the features that I use from the 128 are the relocatable zero page and the relocatable stack. This means that in a few cycles, I can assign a different stack and I can assign a different zero page. And each thread that is running gets its own zero page and gets its own stack. And that means that the context switch only takes, well, a couple hundred cycles, really. To compare, a context switch on Linux takes anywhere between 100,000 and up to 1,000,000 cycles. So on a 1 MHz system, a context switch could take up to a second on Linux, and on OS 128. Looking at it, a worst case scenario, it would be like about 500 of a second. So you can have 20 slices in a second still, even in a worst case scenario. To make I/O possible and to ensure that it is not too much interfering, we need buffering. And that means all I/O is buffered, and all those buffers must be in memory all the time to ensure that when a device has some data, that we can write it to a buffer, and that the task that actually needs it, when it actually gets time, it can just access that buffer, and it doesn't have to access the device directly. This also means that the kernel can decide when that task gets to run again. It only gets to run when the buffer it is waiting for actually has data for it. So with all that said, we get into a few peculiarities, because on a C64, C128, we have all those nasty IEC devices. And the problem with those is that they need a lot of attention. Basically, you need to talk to them all the time, and it's pretty time critical, and it just doesn't work for this. That means that I can support a 1541. I can support a 1571 because it can use fast mode. And fast mode means that it will generate an interrupt when it has data ready, and that I can respond to without having to monitor it all the time. So when looking at what kind of storage I can support, it will be all burst mode devices, including a CMD hard disk, but it won't be any 1541, 1540, and currently also not an SD2 IEC. I'm still looking into supporting Jiffy DOS. I have code for it actually. It supports a kind of block mode, which would make it efficient enough, hopefully. So that's too bad, but that's the way it is. Also, we are missing some functionality in the MMU, and it's kind of funny. About 2 years ago, I had a long discussion with Bill Hurt, the lead engineer for the Commodore 128, about this. And he was complaining about no one using the stack relocation, zero-page relocation. And I was explaining what I was planning on. I hadn't started on it yet. And we started discussing what he really wanted to do. And he really wanted two things. That is shadow registers, which would make interrupts lots more efficient, and some kind of supervisor mode, so you can have memory that is read-only, even if it's wrong. Well, sadly, we don't have that. So that is really missing in this whole setup. That means we also don't have virtual memory, but we do need swapping. And I will explain why, but for swapping, the only reasonable way to do that is to use Commodore's ROM expansion unit, or a clone of it. GeoROM, sorry, no go. It has no DMA, it isn't fast enough. So an REU, Ultima 2 Plus, or such device, or the ROD device with the proper firmware should also work. So looking a little bit at how OS 128 actually runs multiple processes. If you look at a 128, you have two blocks of RAM, each 64K. And looking at it, this is all, well, the first column just says the address range. The second says what is in there for RAM block 0 and for RAM block 1 and for the kernel. The kernel is a function ROM. It's always in ROM. And that means that it can overlay whatever ROM is active at the moment. So you see one process running in bank 0 or block 0, one process running in block 1, and every other process is in the ROM expansion unit. And what I do is when I need to swap in a new process, I copy the current one to expansion ROM, and I copy one from expansion ROM to system ROM. To prevent that from happening too often, the first thing I look at is there a thread in the current process runnable? If not, then I switch to the next process. So if you have a 256K 128, which exists, well, you can expand one. I can use all 4 blocks of RAM. So you can have 4 processes in system RAM at the same time. It's more efficient. It doesn't get any functionality, but it is faster and way more efficient. Looking at how I handle devices, well, no direct access, including display, keyboard, storage, etc. Everything works with I/O streams, and I/O streams behave like queues. You put stuff in it or you read stuff from it, and when you try to write to it when there's no room, you get blocked. If you try to read from it and there is nothing there, you also get blocked. You can prevent that if you want. In that case, you will just get an error if you can't read or write to it. Also, all I/O must be buffered. Hardware will be handled when the kernel has time for it. It will put data in a buffer, and a process can pick it up. And devices are handled by dedicated threads in the kernel. Well, with that, I would like to show a few things, just a little bit. Let me switch to this. And let me actually start the system. This, by the way, is another project of me, that's Device Manager, which some of you may know. I have the luxury of being able to integrate extra software in it, and one of them is OS 128. This is the boot time of it, which is like 3 seconds. First thing to show is I have multiple consoles, so I have 1, 2, 3, 4, and a console with debug output. And one of the things that you see here is that there are two things running, one handling the Ultimate command interface to support the Ultimate 2 Plus card, and one running the IEC interface, or the Commodore serial bus. And you also see 4 times a readline process. I will show what it is. And all of those reserve buffers. And those buffers all come from a shared bit of memory. So going back to console 1, I have a PS command which shows you the actually running tasks at the moment. And you see 4 times a mini shell. A mini shell lives in the kernel. It is a very, very tiny shell, but it's what I'm using now, and it knows a number of commands. It can actually parse command line arguments, and it provides everything to build a much bigger shell. It just doesn't provide many commands. So we have time, uptime, and what so on. Looking at the processes that I have here, you currently see there is a mini shell. I can start a menu which has a few demo programs. And if I now switch to another console and type PS, you can actually see that one of the tasks that is running now is the menu. Switching back to it, oh, I need to switch back to the right console. I can run this well-known demo. Anyone who ever watches 8-bit show and tell has seen this, and many who don't also have seen this. And if I look at the running processes now, we can see it in there. If I start a menu here as well, I can start a counter, and we can see it's now at 200 something. We have here the 10 print demo running still, and I will leave that running for a little while. And switch back, and we see that the counter is now at a much higher number because it kept running in the background. Since I'm a bit low on time now, I see, I'm going to show one more thing, and it is how responsive the system remains. Let me start a menu and not with an argument. I have a thing in here, let me see, yeah, option 6. What does it do? Well, it actually tries to start as many tasks as possible, and it keeps doing that in a loop, and each task is just printing its own ID. If you look, meanwhile, the counter is still running. Going to yet another console. Let's see. Yeah, that one is also still running. Going at another console, we can see that there are many, many tasks running now. And if we look at the debug output, we can actually see when the various processes are starting and stopping. So that is basically how far the system is. I/O is partially working. Storage is, well, I/O is working for the display, for the keyboard. Storage is partially working, and that is the current part that I'm working on. Switching back to my presentation. Let's see. There we go. Yeah, so people keep asking a number of questions about this. And one is, will GRAM or Rambling work as memory expansion? Currently not, and it can't be used for swapping, but I may support them to provide extra RAM to applications. That depends a little bit on how much room I've left in the function ROM. I already mentioned 256K system RAM is supported, and actually gets you an advantage. And well, only 2 processes. Well, actually, you can run many more processes, but you need a RAM expansion. You need to swap them too. And if you have 256K system RAM, you can run 4 processes from RAM directly. Can it run a regular C128 applications? No. However, the Commodore jump table is there. And that means that porting Commodore 128 applications that just use the kernel and only use the kernel jump table, yeah, that shouldn't be too difficult. And last but not least, why? I mean, what is this good for? Well, depends. The first thing it serves is my curiosity. I was actually curious if it could be done, not just in theory, but if it would work and if I could really make it responsive. I already did show to myself that I can. But now I need a real purpose for it. And one of the things that it could be really useful for is, for example, to combine it with a BBS client. So you can have a file manager running in one session. You can have your BBS session. You can download files. You can meanwhile connect to a second BBS if you would like to. And you could also manage files that you just downloaded or look for files that you want to upload, copy them to the right place, and so on. So yeah, usefulness is a bit of a question, but that's what I envision as one of the things that it could be used for. One thing I don't mention here, is it available? Every so often I do release a preview version. I will call it the preview version until I at least have storage support. And I released that in the C128 enthusiasts group on Facebook. Eventually, I will also make the source code available. Same applies the moment I actually get storage working in a way that I like, so that I am not changing things all the time while people are trying to understand the source code, because that is a bit nasty, I think. Yeah, with that, I am at the end of my story, and I would like to thank you for the attention, and I would like to thank the Commodore user group for the opportunity to present this little story. So that's it for me.
Yes, many thanks, Bart. Let's see if we have any questions. I saw a comment passing by, a comment from Andre. I think that's what, at the moment you were explaining that that then you copy from one RAM bank to the expansion unit, and then he refers to that point. He says that's also a lot of copying, because I think before you referred to another system that was also doing quite a lot of copying. Maybe I don't know, Andre, you want to comment more on that, or was that the question behind?
That was actually the question, because you mentioned that switching processes on the stack means copying a lot of data around on the stack, put the stack somewhere else and copy back the other stack. But on the other hand, you only have 2 processes in memory, and the other processes are all running in the RAU, and if you switch them, you have to copy much more data. Isn't that right?
That is correct. There are 2 reasons why that is more acceptable than what Linux does, for example. First of all, I only have to do this between processes, and within a process you can have multiple threads running, and I don't have to do this for each thread. So if you, for example, would consider a file manager, you select a number of files and you say copy those to another destination. The copying could be handled by a thread, and you can get back your user interface and browse to another directory or do whatever in it that you want to do. And the system switching between the copying task and the user interface task does not involve swapping to the REU. So yes, it has to happen, but it doesn't have to happen all the time. The second thing is that copying to and from REU is really an order of a magnitude faster than copying with the CPU from memory to memory. So looking at performance of copying of a lot of RAM, the REU can simply do that a lot faster. So in that way, I prevent the huge impact that copying RAM can have on a system like Linux.
Thank you.
Could I ask a question?
Yeah, sure.
You had processes that print stuff running in the background.
Yes.
And what happens with their output? Do they detect that they can't print anything, so they have to have code for that? Or they print and it's thrown away, or what happens?
They don't have to know about that. When they print to the screen in this case, all they really do is write to a buffer. And there is a task running in the kernel which looks at all the different buffers, and each buffer can be tied to a virtual console. So when there is data in the buffer, the kernel will just copy that to the right memory locations and leave it at that. If I switch between consoles, let me see if I can bring that back. Yeah. Let's stop this thing. Each console has its own bit of a video RAM. So this is running, this console is located at address 0 in VDC RAM, and this one is located at address 2000 in VDC RAM. And so the kernel can just copy it to the right place, and the task that is printing to the screen doesn't have to know about it. And the same applies to the keyboard. When I type things on the keyboard, the system actually looks at what console is currently active, and it will put the keyboard input in the right buffer for that console. And the process that is attached to that console will eventually get that input.
So this will only work with the 80-column display then, right?
That is correct.
Yeah. But so if you have a task that is printing stuff, and then you switch to some other task, and the background task prints 2 lines of text, and you switch back to it, those lines are now visible on the screen.
Yes.
Excellent. Thank you.
That's what we can see here, actually. I mean, this is, well, this is one console, and this is my counter. And if I just switch back and forth between 2 consoles, you can see that the counter changed in the meantime.
Yeah, but it wasn't evident to me if it was actually printing all the time or if the output was discarded while you weren't watching it.
No, it's not discarded.
Okay,
it is printing all the time.
Cool.
And when the buffer is full and there is no time to write it to the screen because something else is really keeping the screen busy, that task will temporarily block. It will just not get any time slices. And actually, when it blocks, it will tell the system like, hey, I tried to write to something and I have no space. And the task, the time slice will immediately end at that moment. And that the remaining time will be returned to the system to run other tasks. And the system won't schedule that task until there is actually room for it to write to again. So eventually, what you mentioned, will the task be stopped if it's in the background and it can't write anymore? Yeah, eventually that will happen. But in the background, the kernel will also try to empty that buffer whenever it gets time. And emptying those buffers actually has a very high priority, which we can see if we look at this overview of tasks. You can see there are cons 1 to 7. And the one that is currently in the foreground actually has high priority. And Let's see, do I say that right? Yeah, one has high priority and the other one should have a normal priority. So the one that is currently in the foreground actually gets a bit more priority also.
Just want to say this is really, this seems like a really impressive project and surprisingly responsive on a 2 megahertz machine.
It is. That is, yeah. When I started with this as just really a proof of concept, I was really surprised by how responsive it was. And that's also why I continued trying to expand it into a real system. Yes.
One question, sorry. The PS command you're using, is that built into the shell or does it load from storage? It's built into the shell.
Yes, it is. All the commands that
Makes it very snappy, that's right.
Yeah, all the commands it currently has are built in. So if we, typing is difficult because actually my screen is delayed. That is kind of, all those commands are just built in. And it can also run commands from disk, except for one slight issue, that is that storage is not reliably working yet. I have a few bugs still in the storage handler, which make it crash when it finishes loading something. And that is a bit nasty, so yeah.
Thanks.
Okay, any other questions?
I had a couple, but you answered them right now. I was looking at this load 100%, and I was just wondering how does it handle when there is just no time. But you just answered that, so thank you for that. Maybe the other one I saved as a question was, you mentioned at the beginning that you would consider supporting Jiffy DOS, but in practice, how would that work? Because then I think that there you need the disk, you need this, you need the RAM. How would you see that?
Yeah, you will need the proper ROM in a drive, but there exists a project called SGDOS or Soft Jiffy DOS. Sadly, the website behind it, H2 Obsession, is no longer around, but I was lucky enough to save the source code for it, and that is open source. So at the moment that I actually have the source for this project released, I can also integrate the code from H2 Obsession and integrate their SGDOS code, which allows me to support Jiffy DOS without actually needing Jiffy DOS ROMs in the computer itself. Which brings me to one thing I didn't mention really. I do not use the Commodore kernel for anything. So in theory, I could turn this into a kernel replacement if I really wanted to. It does not use kernel for anything.
Okay, great. Many thanks, but I don't see any more questions in the chat. I'm looking on Facebook neither, but I guess like usual, if someone has a question, they can still post it in the chat. So thanks again. I will stop the recording now.
Okay, thank you.
And then I can call the next speaker, who is Davide. I guess you're
Hello.
with us. Yes, hello, Davide.
Hello, everyone.
Just give me a second. I don't know if you're sharing something. I will start the recording in the meantime.
Yes, I'll start sharing now.
Davide on Toki
Can
Remastered
you-
for C64. I see a black screen for the moment. Yes, no, okay. Just wait a
okay.
second. Just wait a second.
Okay.
Yeah, recording has started. It's
Okay,
yours,
okay.
Davide.
Okay, hello everyone. Again, it's a pleasure being in this event. So we are talking about Toki C64 Remastered, which is a project I started back in February of this year to bring the C64 conversion of the Toki arcade game by Ocean to bring it closer to the arcade, because it's a game I'm very attached to, and it was not the best version possible. So I'll get to that quickly, but first something about me so you can understand where I'm coming from. So I started getting passionate about computers with my C64 in the early 80s. And I also started doing some pixel art right before switching to Amiga 500 at the end of '92. So I was a bit late to the Amiga, and I spent a lot of time with my C64. And I remember doing with the Koala Paint several renditions of arcade games I love, such as Street Fighter 2 and so on. And yes, this love for arcade games was kind of a bit frustrated when I, during my C64 and Amiga days, because many conversions were not satisfactory. So this I kept this feeling of anger and bitterness with me, and it resurfaced in recent years. By the way, I love playing video games, but I also started making them when I had my Windows-based PC back in 2002 until 2008. I made several homebrew games with tools such as the Games Factory, Multimedia Fusion, which, to my knowledge, they were made by the team who made Amos on the Amiga. First, I had a coder that actually helped me for our first game, the one you see up here, the one with the chameleon, which also won a prize in Italy. But later on, I started learning how to do games with such tools, and then I made more, and I basically released most of them. There are a few that are left unfinished while in later years, but I do all the pixel art for them, and so I also learned how to do decent game design, how a programmer thinks when writing games. So this came in help in recent times, and so I really liked doing pixel art, but then I stopped because I had more important things to do and I had no time, and so my passion wore off. And then a couple of years ago, I also joined the Zap Italia. So it's the Italian version of Zap 64, which is a magazine that I used to buy when I was young, and then it came back recent years after the return of Zap 64. And so I joined as an editor, and I've been reviewing games for more than 2 years now. And I had the opportunity to appreciate how the community is really thriving with passion, with making games, but also with fixing old games to basically make fans happier. And I really appreciate that. And after a bit of time, I decided I wanted to do something similar. I basically decided I'd love to do new commercial games for any 8 or 16-bit system that I owned or not, because I'm very passionate about games. But I can't do that alone because I'm no coder. I'm a pixel artist, an amateur pixel artist. But I actually never did pixel art for C64. I did a bit of illustrations, but not dealing with sprites and so on. So I decided my first game would be a C64 game, but I wasn't ready yet to do that. And to learn how to do proper graphics with the C64, I thought maybe I should start by revisiting a game that I love, but maybe was mistreated. And so I instantly thought about Toki, because it's an arcade game that came out in around 1989, but actually it was distributed in 1990. And I first saw it in Italy at a local bar near my house in the summer of 1990 during the World Cups, soccer World Cup. And me and my friends went crazy about it because it was very quirky, very nice looking, very playable, nice catchy music, very tongue-in-cheek. So when I saw the advert for the C64 version on Zap pages of Zap, I was very happy about it. But unfortunately, the conversion of Toki never came out in Italy. It was meant to be published on cartridge, but since the market was very little, we think that the Italian distributor at the time, at the end, did not distribute the game. As far as we know, the game never came out. I sure never saw it in stores, so I basically waited for it a couple of years and never actually saw it. I only saw it years later, around 2000, when emulation started appearing, and find out that the game I dreamed to play on my C64 was actually not the version I hoped for. It was an above average conversion, that has to be said, and especially after working on it, I really appreciate the work that went on it from a programmer's point of view, because it's very faithful. It's an above average conversion, but still has some flaws, especially for a fan like me of the game, which knows every pixel inside and out of the arcade. I can't unsee the ugly sprites. You can see here the grayish colors. You see, they chose for basically the global colors for the sprites. They chose dark gray and light gray, effectively making the game look very dull, as you can see. Also, the backgrounds were good, but the last one was very lesser quality. The soundtrack is fine, but the music does not sound like the arcade at all. And it's a bit frustrating to play because you basically jump when you don't want to, and the collisions are unfair. There are also strange bugs and mistakes. For example, they they completely switch the colors in the final sequence, for example. So there's a bit of problems with Q&A, with QA, quality assurance, and I'm sure they rushed it out at that point. But the sprites really scream for justice because it seems like they were drawn by really someone who was not a graphician. And so by the early February 23, I started doing some mock-ups to test how I could improve upon this game. And I started posting the same picture here, as you can see, on forums like Lemon64 and Facebook to look for someone interested in helping me, basically not rewriting the game, but reverse engineering and editing the existing conversion, because I thought it would be harder to find someone interested in building a game from scratch. It's such a long and demanding process. It would be easier to find someone interested in fiddling with an existing game. And as you can see, the first tests I did were encouraging. Okay, I think I thought I could really come closer to making justice to the arcade. The first step was to choose upon the global sprite colors. So instead of dark gray and light gray, I went for brown for the dark shades and yellow for the lighter tones. Why? While this choice is does not suit all the situations, it is the best possible for Toki, in my opinion, because the first thing I wanted to achieve was to have the ape, the main character, Toki, to really look like the arcade. So it had to have a yellow face and a brown fur. And this was only possible if the global sprite colors were yellow and brown. There was no other possibility to achieve such a result. Okay. So having published some help requests online, I soon found company. So the team, this is how the team looks like now, but it was a gradual process. So the same day I posted online, Mariano joined me. And after a few days, even Pasquale joined the team. And those are two amateur coders. So they have little experience, just like me, but they were very motivated and interested in fixing Toki with me. And so we started finding ways to bring the sprites into the game. And to my surprise, Aldo Chiumo, which is the musician to A Pig Quest, a very important game that came out this year on C64, he basically sent me his version of the first level music, and he made me this surprise, and it sounds amazing. And in a few days, he sent me all this, the entire soundtrack to the game converted from the arcade. It's stunning. I haven't shown it to anybody online, so it's still under wraps because I'm waiting to have the game in a more complete state and make a video. But I can anticipate that it's already sounding great. At a certain point of the process, I mean, after 3 months, Mariano thought it was time to seek for help and find out that Ewan Gamble from Australia is really talented in the disassembling and reverse engineering C64 games. And Ewan is one of the guys who probably put the many hours into the game, just like me, to fix stuff. So it's very, very important that if you see the game, the state it is because Ewan really spent a lot of time. But in the first weeks of the project, Mariano and Pasquale were fundamental because without them, the project would have died. So how do we fix Toki? Well, first of all, our communication is on Discord and the project is stored on GitHub. And then the coders use these tools to analyze the code and put all the new sprites in. So they also did custom scripts. The first were made by Mariano, and then when Ewan joined, he wrote a custom Python disassembler, which is amazing. Unfortunately, you'd have to ask him to show it because I don't have more details to explain. It's not my field, but believe me, it's really, really interesting. As far as my activities goes, I use paint.net to draw the graphics because it's a free tool that has a really a learning curve, which is very, very short. So I started doing the fun thing, the graphics really soon. I did not have to learn to use a complex tool. And also I use SpritePad Pro and Chartpad Pro to finalize the sprite sheets and the chart sets that then will go into the game. Oh, so this is a preview of the results of my work on Toki. And as you can see, even though I actually drew the Toki sprite only in September, so it is one of the last sprites I drew, because I waited to master my skills in converting the graphics. But as you can see, it is just like I anticipated. I just needed to have the yellow face and the brown fur to achieve the maximum possible fidelity to the arcade. So since this is the main character, the one that the player always sees on the screen, this sprite makes the game. This has to look good. It has to look just like the arcade. And this is what I set out to achieve from the very first second of the project. I'm really happy how it turned out, but it was really a lot, a lot of work because I'm not a professional pixel artist. It is a very fun activity, converting graphics from the arcade actually, but it takes a lot of time. And as you can see, even though I'm no professional, my results I dare to say a lot better than the original C64 version. So you understand that actually the original graphics were really not up to snuff on C64. They could really have done better, but I think they outsourced the work to the job to someone who's not skilled at all on graphics. Unlike the guy who did the backgrounds, which is very skilled. And as you can see, the color scheme I choose most of the times lends to produce very good results. For example, take the zombie ape here. How can you call this a zombie ape? It's so gray. It's unbelievable. The same with the pike here. Oops, sorry. So by reinstating brown and yellow, it really allows me to have a colorful game which looks like the arcade and not just like Terminator. You see, this ape here looks like a robot. So, for example, here I don't have I cannot have the orange for the skin of the big ape head, but it's still very close to the original. So not in all cases my palette choice is perfect, but it is in most of the times, and still it's colorful. So for example here with Neptuna, the original actually has better colors, but there's no way I can achieve that and also have Toki looking like this. Okay, so there are compromises to be made, and the choice I made, I'm certain that is the best to express all the colorfulness and the quirky character of the original game. Okay, so what's my workflow? I use PaintNet, as I said before. And after I basically come up with a decent rendition of the sprite or the background, I then switch to import them into SpritePad or ChartPad Pro to then build the sprite sheet that the guys import into our build of the game. How do I proceed? Basically, then I'll show you with the video, but I anticipate it here. Basically, I create a new picture with at least 4 layers. I have the arcade layer with the original sprite ripped from the arcade. I have the original C64 sprite in another layer. Then I resize the original arcade sprite in order to have a reference for something that will fit the C64 number of sprites that compose the character. And then I start drawing on a 4th layer, which goes above the resized arcade version. So the first step is I trace the main color areas, then I detail, and then I start messing with pixel until I get the best possible result. Now, if I want to show you a little video of that, I don't know if it will work out of the box. Can you actually see the new video?
I think you're still sharing the slides.
Okay, let me see. Now, is it working?
Yes, I see something.
Okay. So this is a screen recording of me working on PaintNet. As you can see, basically we have. Okay, this is the original arcade sprite. Let me see if I can. Okay, this is the original arcade sprite already shrunk down to fit inside the size of a single C64 sprite. And then I have a layer on top of that where I basically drew the basic colors areas. Okay, you see, so I basically drew over it with the blues, so they stick out on the green. And basically got the basic shape of the character, and then I start putting in more details. For example, like the spikes here. You can see I go clicking a pop-up menu, which was not captured on the video, but each time I try to turn on and off the layer so I can see what's behind, and then add the details. I basically do the double wide pixels myself. There's no option to have a 2x1 brush. So I go on trying to, basically, this is my technique to achieve a flawless, as close as possible conversion of the arcade graphics. So I'm not editing the existing C64 sprites. I'm redrawing all of them from scratch using the arcade graphics as source material. And so after a lot of back and forth between the layers, I come up with something like this. Okay, this is the final result. So it's not as good looking as the arcade because I have to stay within the limitations of the original C64 version. So this guy here uses just one sprite, and this is the best it can be done in such a low resolution. Okay, back to the presentation. In Toki, there are around 700 sprites, counting the intro and outro sequences. And of the in-game sprites, basically, as of today, I've done 512 of them. And there are 67 more to do, while 63 are work in progress. I also found out there are unused sprites. Some the game has are freeable because they actually have more sprites than they use in the code, but we are not going to use them because editing the code will be too much work actually. So how do we work as a team? Basically, after I draw my sprites in PaintNet, I have to export them in Sprite.pad Pro and cut them, you see, in single sprites. Because as you can see here, the bigger enemies use several sprites. And actually, Toki is a very complex game. So really kudos to the original coder because it really did a great job to recreate the original arcade. But unfortunately, it was let down by subpar sprites. So basically, we have a whole Google Sheet document with every single sprite that is in the sprite sheets that have been dumped from the game is traced here with the same ID, which is shown in Sprite.pad Pro. And then I specified for E1 the color he has to state into the code. Okay. So this is both a tool to track my progress and also a reference for the coders for the colors that have to be changed into the actual game. So this is basically how the sprite sheet look like. For example, this is one of the banks we have. So I was saying, Toki is really complex. Many characters are made up of several sprites. Toki himself uses 3 sprites. The bosses are huge, and this poses a problem because since I want my goal was to have the game look as much as close as possible to the arcade. That means that several solutions the original designer chose for C64 version actually are a problem for us because they prevent us to achieve a perfect fidelity. Even if it was actually possible on C64, we have to deal with the limitations of the actual version we are working on. So, for example, there's a frame of this guy here that I can't replicate perfectly just because we cannot change the position of the legs because they are the character is coded in a way that not all sprites can be moved easily. Moving all of them farther than a certain threshold would mean rewriting a large part of the code, while instead we are only modifying some values, so, for example, offsets and starting position and so on. So while the guy is almost perfectly true to the arcade, there are some frames of animation that cannot be because of this limitation. At the same time, you can see here, this guy on the right, this looks completely wrong because of the way I optimize the use of sprites. I'm not happy with just using the way the sprites were used on the original version. So we are actually rearranging them as much as possible. But to do this in certain cases, such as this boss here, it's not something we can still do because changing the position or the offsets of the sprites means we have to understand how the movement of the whole monster is written in the game. Because in his case, the position of the sprites is built into the code that manages the movement. Okay, so we haven't yet understood how the game moves some objects, and we cannot fix the graphics until we also disassemble that part. So it's just a matter of time, but unfortunately, we cannot anticipate how much time it will be needed to fix certain aspect of the game. In the end, we will surely be able to. Okay, so I don't know if I have some more time. I can show you a gameplay video of where we have come if you want.
If you can do very short, but that would be nice. But
Yeah,
indeed
sure.
a bit delayed. Yeah.
Okay, I'll just very quick. Okay. Okay. Okay, so this is level 2, just to show you, because this is the first time I show level 2 with all the sprites changed, even the bubbles. We have changed the color because it was gray in the original. Now it's clearer. So this is all, except for Toki, this is still the old sprite. But all the enemies are new versions, so much more colorful, better animated. And you can see here Neptune in all of his glory. The sprites disappear because there are too many of them. This is a problem with the sprite multiplexer. And as you can see, here we have the guy I told you before. This is completely messed up, but it's working. But it looks bad because the sprites had to be repositioned. Also, I'm very proud of this guy here, which looked really bad in the original. Now it's looking a lot better. It's still unfinished because we have to change, fix the position of some sprites, but this is very, very looking very, very better than the original, which was basically gray and yellow. Okay, I guess I can stop. One last thing I want to say. Our team is open. We can have all the help we can get. So if there's anybody who wants to have fun editing an old classic and making people happy to see it fixed, then we are more than happy to welcome him in the team. Okay, that's it.
Good to know. Many thanks, Davide. Actually, one I don't know if there are questions, but one thing you mentioned at the beginning that you were frustrated with the version of the game. I think we all had that, especially because at these times, it's like the hardware that you could have in in the arcade was more or less the same as what you could have in home machines, right? So only home computers. So it was a bit frustrating to see that they get much better results in those gaming machines. Maybe just a couple of questions from my side. Maybe you mentioned that, but then it escaped my attention. What is then your timeline for the release, or do you plan to release like a couple of levels whenever they are ready, or do you wait for having the full version available? And how do you plan to distribute that?
Oh, okay. The game will absolutely distribute it free. It will be only digital. We do not have the rights to create a physical product. We're not going to sell it, so it will be absolutely free. And my intention is to release it during the next year, as soon as possible. Realistically, it won't be out before June. But my intention is to have most of the features that I spoke about at the beginning, so music, backgrounds, and sprites. I'm almost done with the sprites, but they are not all of them into the game. The backgrounds, I started doing them. But the actual problem is with certain aspects of the game. If we want to fix them, it takes a lot of time before you want to find out how they work. So we cannot do a proper calculation about how long it will take to fix it. So if it's gonna take too long, my intention is to release a version that has at least all the sprites changed. Unfortunately, maybe without the new music or gameplay fixes, because that realistically will take a lot of time. So maybe there will be a first version with all the sprites and then a final one with all the other stuff. This is the worst case scenario. In the best case scenario, only one version with everything in. If everything goes as planned, if my buddies don't have personal problems or life issues that get in the way, because it happened to all of us in turn. So work could have been a lot faster if we didn't have families, jobs, and several issues that crop up every now and then. So this is with all amateur projects like that.
Yeah, of course. Good. Many thanks, Davide. I don't know if there are other questions, but looking at the time, maybe if people have questions, they can just post it in the chat. I will stop the recording now. And then for the next speaker, so we have a little switch. I asked to swap between Andre and Dusty, because I think, Andre, you are taken by the time, so then you will go next with GeckOS or GeckOS, whatever you pronounce it, version 2.1. Just give me a second. I see you're sharing already. I will start the recording. And many thanks, by the way, to Dusty for agreeing on the switch. And sorry about the time delay, but that's a bit how it goes when topics are interesting and we just leave them on. So I start the recording. Yeah. Andre, we need to unmute. You're still muted.
Okay, thank you everyone for joining this call, and going to present my multitasking operating system, GeckOS. And luckily we've had, I hope Sebastian will link that in the description, the multitasking on the Commodore 128 call before that, so I can skip over a little bit of some of the details. So why is multitasking a challenge? We've heard about that. We have fixed addresses for the stack and zero page. We have no position-independent code, and we have no memory protection. So looking at the past, when I started all that, it all started in 1990 or maybe 1989 when I built my initial Commodore PET clone, and it was using an MMU. So here you can see a picture of that machine. So the MMU was able to split the 64K of memory into pages of 4K each, and could map that from a maximum of 1 megabyte of memory that was available on the bus. So because the BIOS board, what I call it, had 32K of RAM, and the video board has 64K of RAM. I already had 96K in the default configuration. So that was very nice, and it ran up to 2 megahertz. So that was what GeckOS was made for. So the MMU was translating the upper addresses at the video card with the CRTC like the pads, mostly PET compatible I/O and other I/O on PCB cards. So when you talk about multitasking, so I shortened this all a bit because we had this talk before. We need to look at where each task resides in memory. And the memory management unit on this PET clone made it very simple because every task had its own memory map. So we have the kernel that has some 4K of kernel memory, private kernel memory in the bottom, where it has its own stack and own zero page. And we have the kernel itself, which is 4K in size on the topmost page. And that was what the kernel would see. And it could, of course, because it's a kernel, it can also remap other pages of memory to access memory that's actually owned by one of the tasks. And each task has its own, has the same kernel mapped into its memory, but it has its own separate memory RAM at the bottom of the page. So it has its own zero page and stack. So that was easy. You could just reserve some of the memory in the 32K here static RAM or in the video card RAM to map that to the different processes. So it is even better than the 128 who can that can remap zero page or stack, but we could also completely remap the whole 4K. And there were programs that just ran in this 4K very fine, much fine. And all the rest of the memory was just not writable. So how did GeckOS work, or GeckOS 1.0? And it's basically still valid in GeckOS 2 point something. It's a microkernel, and the kernel is only doing the inter-process communication. So we have the devices part of the kernel, we have an environment part, that's what I call it. It's the management of the memory areas of the, if you go back to the previous page, each task here had its own, what I call memory environment. And that's going to be more featureful in version 2, but I come to that later. And there is a file system manager, which is basically mapping drive numbers to file system tasks. So you could send as a normal shell or monitor or whatever task, you can send a message to a file system manager to say, okay, let me load or open this file from drive 0, 1, 2, 3, or 8, A, B, C, D, and so on. And the file system manager would map it to different running tasks in that that are running in parallel, all on the same system, and then the file system, the task specific for that device drive number would react. So, for example, I have a device file system that maps devices to files, because I was kind of looking at the Unix philosophy, everything is a file. I have IEC bus, which is able to support, actually it was able to support parallel IEEE 488 from the PET before it was able to support IEC from the Commodore 64. I have, here it's still called FS IBM. I should change that to FSFAT. So you can use PC floppy disk drives, which I have an expansion board for my PET clone. Those are the main file systems supported right now. And there is the stream module, which does the data communication between tasks, which is unfortunately still byte oriented, but there are some plans for maybe call it GeckOS next generation. And then there is a memory management that manages all the memory allocations and so on. And devices are here on the other side of the kernel, and they are running in the interrupt. So they are being called from an interrupt, which is typically running from the screen interrupt, so every 60 hertz or so on. So that was GeckOS 1. What further development, and that was in 1990 or something. So I created a TCP/IP stack using SLIP, serial line internet protocol. I actually had a GeckOS machine, Commodore 64, with the user port 9600 baud interface on the internet, serving one page and one little GIF from a 1541, which is hellishly slow, but it worked. Occasionally it crashed, but still worked in some way. You could actually you can log into the operating system from the internet. Not on this one, but if you put it on some local network. And then going to version 2.0, I did a kernel rewrite. I implemented threading, and that means I have a complete hierarchy. I have the memory environment that can have multiple processes or tasks, and each task or process can have multiple threads, and this is all stacked, and every stack has its own thread. I have dynamic memory management. I have relocatable binaries, because in the original MMU version, I could just assemble the programs to a fixed address, because that's where the program started in their own memory environment provided by the MMU. For the C64, I needed a way around that. My way around that was to create the 065 file format together with and then build it into the XA65 cross-assembler. So I was able to build my binaries as cross-architecture binary that run on all the supported platforms on that OS. It's even using late linking because the kernel on the different architecture is on different addresses. The libraries are on different addresses, but you can just load the programs file. They will be relocated to their address in memory when loaded, and it will linked to the current address of the kernel and the library. So what other features are there? There have been in 1.0 already some that have priorities. You can decide how many time slices a task can get. You have virtual consoles. We've seen that in OS 128 as well. Signals, semaphores, backgrounding, redirecting, piping. You can use shells, very similar to a Unix shell. There is a standard library I call lib6502. I think there is another. I think Lunix. I'm not sure. Is using, or some other operating system has support for those as well. And already mentioned the cross-assembler and the file format. Currently supports, of course, my clone, which the latest edition, if you can see in the camera, is still here. The Commodore 64, even the 32K pad, but this is basically so memory constrained that you can only run, say it's tech demo. But the 8296 Commodore pad, which has 120K of RAM, where you can actually use 96K of RAM in a special banking configuration, is very nice. Unfortunately, the 128 is still missing due to time constraints, but the plan is actually to do that as well and use the relocatable 0-page and stack there for task switching. Demo time. So you just load it like that, and when it's loaded, can you see the widescreen?
Yes.
Very good. So let me get out of pause mode. So this is how it comes up when it starts. What you can see here is there is an init process that reads a list from what is still called some kind of ROM, yeah, and starts the processes in that boot image. You can call it init ROM disk, but it's not really something like that. But it's a boot image that has the init process, the device file system, and the IEC file system in here. And then it takes loads the shell from disk. So, but if you can look at the devices we currently have, and here's a difference between those, between the previous one. It's also memory constrained. LS is an external program. LS is loaded from disk before it actually executes and shows the data from the disk. There you can see we have a serial device, which is the 9600 baud user port. So yeah, I can do NMIs. It's complicated, but it works. I have multiple consoles. I can do a shift tab, go to another console, 3 actually, even though there's 4. There's some null def. You can pipe stuff in there, and it's done. So if you go show uname, this is actually built in, so it's very fast. So it shows what the version of that one is. It's actually wrong because it should be 2.1. I have to change that. You can have, you can actually, because I said this is, all processes are in the same memory. They're not swapped out or anything. So I can have a program that shows you the memory allocation of that system. And as I said, it's relocating all the binaries every time when it's loaded. So you can see here, this is LSMem is a special program that does that, and -z shows the 0 page. And for every byte you can see, yes, every byte, you can see which process is actually using it. 0 is process number 27, it's the actual shell. 1 is process 34, which is the LSMem itself. What you don't see are those that are started from the boot image, which are hidden behind those others. Those are not used. So I can actually start another process on a second, terminal, second console. So let me load that, and I'm going to cheat a little because time I'm going into warp mode, and you know I'm not into fast loader, and the reason for that is because I'm coming from the pad. The pad has a parallel bus. Parallel bus is about 5 to 8 times faster than IEC, so I never needed a fast loader. The first thing I did with my Commodore 64 was actually I gave it an IEEE 488 interface and converted my 1541 into parallel 2031. So if I have a call for action, for help, that's one of the things I could need some help. So what you have here is you have, I started on console video 2, another shell. And if I switch over to the other shell, I have a second shell here. And this one is running, again, LS is loading from disk before it's actually showing the directory. So what, and there I'm back. I'm still on the other console. It's still there, and there's the other one running, and it works similar as has been shown, explained in the previous call. There is a buffer for each program. It writes its output to. This output gets sent to the console. The console is running in the background. If I can start I have a monitor, but it takes a long time to load, so I'm not showing it here. And let it run through all the memory and scroll it through. It will scroll in the background, and you can go to another console and do something else, and it will scroll by and continue to scroll. And the program will run as long as the console is taking the output out of the buffer. So now when I go to and show me the memory output of the system right now, you can see that there is, and this is now M is the, I'm going into, oh, there it is, okay. And M is the memory map, so it's approximately by memory block. You can see the 0 is again the first shell, 1 is the LSMEM. And you can actually see there's two entries for the program, and one of those is the data that is used by the library. And 2 is and then the other one is the rest of the program. And there's a second shell that is running in the background. Yes, the other console. You can also do a PS, which is also loaded, and that's why I asked, because in the previous call it was very snappy. It has to be loaded from disk. It takes a bit until it starts. And then you can see here the init process, the device file system, the IEC file system, the shell, the PS command, and the other shell that started on a separate console. You can see here, this is the signal address, and it's all the same. The Commodore 64 only has one memory map, and it's not copied over. And the reason why this works is because the library that handles the signals is re-entrant, and that's what is this why it needs its own separate memory area. And you can and I'm going to show a demo program for a semaphore log. You can which is from Tende, Glenn Holmer, he wrote, and it starts one process and logs a semaphore, and then runs another process that waits for that semaphore, and then you have to hit the key here to free the semaphore to make the program run. And if you go and look at the PS in the background, you can see all the events are running in memory. So you see the log and you see the block, and you could also see if you want to do that, you could see the memory map and so on. Then I press the key here. It should be. No? Okay. So the program has released the log. The second program has taken the log, the semaphore, and then released it again and ended it. So you have this different means of inter-process communication. Okay, so let me go through back to the slides to keep time. I think I only have 2 minutes left. Okay. So if you want to program with GeckOS, that's very easy. You can use low-level kernel calls. You can use lib6502 level. It's all cross-architecture. The binaries are compatible, as I explained, using the relocatable file format. There's extensive documentation available in ASCII doc format about the different ports, about the kernel calls, about the library calls. For example, here is an example for the psem semaphore, which is actually in this demo, which I showed. So in the future plans, I want to expand on the controlling terminal, so you can actually do some kind of Control C in a more standard way. I want to unify the communication between the different tasks, which is now byte-oriented. I want to make it more block-oriented to save more space, much more. And I want to support the UltraPad, the Commodore 128, maybe even the Apple II, or the BBC Basic to it. And it's all open source. You can have it here. There's a video series I have on YouTube. There's also Sender's commentary on GeckOS. We even had put out some HTML documentation, which I can gladly link here from here. So that's it for a very short run through GeckOS. Thank you, and I'm waiting for questions.
Many thanks, André. Maybe I will kick off the first question. You didn't mention any RAM expansion unit here. Is it? Did you try? Is it working? I mean, is it foreseen to be using that? And if so, would it be then possible to maybe, or if not, maybe if. I was just thinking, would it be possible if you are using a disk or something, or some external storage, to use that as extra virtual memory?
There's two questions here.
Yeah.
Your RAM expansion unit, I actually only got one this year or last year or so, because the Commodore 64 is not my primary development machine. I'm very much pet guy, and I'm working on these pet clones. But yeah, I have an idea how to hook the RAM expansion unit into a file system path, so that can actually be run as some kind of cache. So if you load a program from disk for the first time, it would be also stored in the RAM expansion unit, and then automatically taken from there. You load it next time, which would definitely greatly speed up the loading.
Mm-hmm.
The second one was virtual memory and paging. That's a good question. The problem is, if you page something out and you want to page it back in, you have to page it into exactly the same addresses.
Yeah.
And if you have such a memory constrained system like the Commodore 64, it's very difficult to. In the meantime, you have started some other processes and so on. To have that RAM, these address ranges actually available again. So in the 128 operating system we saw before, that was easy because there were actually only two. I understand, one process for the GUI, and the other one was basically swapping in and out the background processes. And they were not relocated, so they all on the same on a static address. So that was working fine. I could do that similarly, but I'm not sure if I want to do that. That would be quite some change. So for now, I'm more concentrating on looking at machines that have enough RAM, and then see how that works out. Okay, has to fit into memory.
Maybe in version 3.0 then.
Yeah, maybe.
Good. Many thanks. Is there any other question? Yeah, really running late.
Yes. Just wondering, how do you exactly handle a stack per thread? Are you copying the stack around, or do you split the stack in multiple parts? Or
actually, there's two options. Exactly those. Because it's a microkernel, you can have it in the full-fledged version like I've shown, or you could just use the 4K kernel, use the process switching and interprocess command, and build a minimum system. So in non-MMU systems, you have two options. You can split the stack, but that restricts the number of processes even more.
Yeah.
In this version, it's actually copying the stack over. But of course, it only copies from the stack pointer to FF. So, and what I found is this is not really much usually. There is not so much stack usage. I mean, if you're running basic Commodore Basic, which works on my full MMU machine, but not on the Commodore 64, because there's really not enough memory for that again. And especially not, or maybe it would. I have to try. But
yeah, if
anyway.
you just use the stack pointer, it's not that much copying. I can see
Sorry?
that. I said if you just use the stack pointer up to whatever the top of the process stack is, or the thread stack, then it's not that much copying. That's true. That should be workable. Yeah, you made an interesting comment about relocatable code, and I ran into exactly the same thing. Like if I do that, then I have to move things around all the time to ensure that the space is available again. That's why I made a different choice. One comment: it's not like one process running the user interface. You could. There are really two user processes in memory at the same time, and there can be 32 of them if you want to. That's just a lot of copying. The kernel is its own space, and it doesn't need the normal space that is used by processors. So the consoles and all that it doesn't need any RAM from that's normally used for a process. So you can have two real complete user processes, which are multi-threaded and can use a user interface on one thread and whatever in the background on another one. But that's quite similar. I was surprised by the similarities, by the way, by looking at what you're doing and looking at what I'm doing, and seeing also the different choices we made due to different hardware considerations, memory considerations, and so on.
Yeah, I see. There is also C64 OS. Greg, I think I don't remember the exact name. So he's doing also like stuff with the REU and all that. So I thought, well, I should probably support it. I only have limited time available, and as I said, my main development platform are my pet clones. So I'm not very experienced with the REU and fast loaders and that stuff. So if anyone feels inclined to help me, that would be very.
I have commented source code for a DVDOS implementation if you want. That is open source. It's GPL though, so you need to be open source as well. That's the only thing.
Yeah, of course I'm on a GPL. So
then that would work.
Yeah,
good. But let us maybe park just looking at the time, Bart and Andre, many times. I think it's really interesting. But you can also maybe park that discussion and take it offline. I think just for the sake of the time. But I understand it's of course overlapping or very close in terms of the approach. The two systems and very, very interesting. Many thanks, Andre.
Thank you, everyone.
And thanks as well to Dusty for having allowed the switching or the swapping on the agenda. I will stop the recording now. And Dusty, I know you had some issues with the connection. Are you back with us? Yeah, perfect.
Yes, hello, I'm back. I don't have video though, but I can share the screen.
Okay, that would be perfect. There's a little bit of echo, at least when I speak. But let's see if that's,
I don't know what to do about that.
No, but I will just shut up and, and let you talk. When we talk, there is no issue. I will just start the recording so that you can start.
This meeting is being recorded.
Okay, I can start maybe by sharing my screen. Let's see. Okay, can you see my screen?
Yes.
Okay, good. Thank you. Yeah, please let me know if you can hear me clearly and if you can see the screen fine or not. And thank you for inviting for a short talk during the Commodore Users Europe. So I started with a few slides I made about this thing that I put together called Oscar 64 double P. What does it stand for? It stands for, it's a preprocessor for Oscar 64. So then you may wonder, what is Oscar 64 that I made a preprocessor for? Well, it's a C compiler. It compiles to the Commodore 64. It compiles PLG files. And it runs on the Windows and Linux. And it's actually pretty nice C compiler that I discovered lately. And there's pretty good support for it. There's a person calling himself Dr. Mortal Wombat. And he reacts really quickly to questions when you're using his C compiler. You should give it a try if you like to do some coding for the C64. Besides that little commercial for Oscar 64, let's talk a bit about Oscar 64 preprocessor. So why did I make it? Well, I was creating a game. It's called Snake Escape 64. And I went through a whole bunch of C compilers before I was happy. I started really with something called, I think, CC65. That was a bit slow. It was nice, but it was a bit slow. Then I landed on KickC, which I really liked because it was really, really quick. Except that when the program became bigger and bigger, the compilation time became longer and longer. And at some point, I couldn't really develop the game anymore because, the compilation time was more than 50 or 40 or 50 minutes. And that made it just really painful to work with it. So I sort of paused my game. And then I found some guys on Discord talking about this thing called Oscar 64. And I thought, okay, well, let's try it. I was more or less happy with it, but I was missing some features that KickC had. So what are those features that I was missing? And let me just show you quickly so you maybe can get an idea what I'm talking about. So here's my project for, let's see if this is the right one. Yeah, for KickC. And if I open one of the files, and if I search for the, and excuse me for the very messy coding, but if I search for this part, here you see it's doing some magic coding using Kick ASM, and it can include a PNG file directly in your C file. So it's directly converting your PNG to some binary data, which you can use in your Commodore 64 program. And I really built my whole game on this feature, really, but it wasn't there in Oscar 64 preprocessor. So then I thought, well, it doesn't seem to look that hard, really. This is just JavaScript. So why don't I just enable Oscar 64 to include JavaScript? And that's exactly what I did. And this is what my preprocessor program is all about. So let me continue with the next slide then. So yeah, it's a tiny preprocessor script. It takes some C code and it has embedded JavaScript code in it, and it executes that JavaScript while you compile it to create more C code. And it stores this generated code in the generated folder, and then it calls the Oscar64 C compiler. It wraps around it and to more or less compile the resulting code. And just like the main compiler, it also runs on Windows, Linux, and whatnot. So some use cases, some reasons why I use it. Well, I like to create some of the data algorithmically because it goes much quicker than doing it on the Commodore 64 itself. I did that before, but then I was waiting like a whole minute before I could start my game. So this is one of the reasons. Another reason is the very handy importing pictures into the code. This PNG file example, which I just showed you in ClickC. Why do I need those actually? Well, you can use it for many things. Character sets, sprites, title screens, and so on. So how does it look like? Well, all JavaScript is supported, and you have some special keywords. So here's an example. Here is just normal C code starting with jar, cross, square bracket 256 to define more or less an array in C. And then it defines it. And then in there, I put a comment. And the comment starts with, well, as comments start with a slash asterisk. But then after there, I got an exclamation mark and CGGS, so code generation for using the JavaScript language. And then you can put anything behind it on the line. I just put a lot of dashes there to make it easy visually to separate from the rest of the code. And here's just some JavaScript. Const amplitude is 127. It does some stuff with the mat library. It more or less calculates the values for cosinus. And it returns those back into the main C file by using the .byte command. And yeah, this is more or less how it works. It's pretty simple, really. So here's another example. Another thing you can do with it, load a picture, as I mentioned earlier. You can load bitmaps, just like the one you see here, that only have one color or two colors. You can also use bitmaps that have multiple colors. But in this example, it's only using one color or two colors, sorry. So how does that work? Well, it has a few library functions built in. This Oscar64pp or double P. So load picture, and then you can just point to a PNG file. And then you need to go with two for loops more or less through the Y and the X dimension of the picture, and you need to do some magic here by figuring out the coordinates, and then you can use this when you have this picture object, you can do a get 8 monopixels command, which more or less gives you a byte back. And this is the way the Commodore 64 memory is more or less organized for monochromatic pictures. Each bit in the byte is a pixel. And yeah, then you can use again this byte command, or in this case, the H byte command, because it wants to return an hexadecimal byte. You can choose if you want that, or if you just want decimal values, it's up to you. And then you can use it. The picture here above is what I'm loading. So it's just a character set, which I can use for my game. Then how to call it, the preprocessor? Well, you need to have Node.js installed because it's a script created in Node.js. So you type node, the path to the Oscar 64 P, then the path to Oscar 64 binary, then the temporary path where it puts all of those files that are being generated from the original files, then all of the other options that you will pass to the Oscar 64 compiler, like -i to include something, -i to include something, another folder, -o for the actual output PLG file. And after that, all of the source code files, which will be transformed using the preprocessor. Yeah, okay, so let's do a small demo. Let's see if I have it prepared. Okay, so here I checked out the Oscar 64 preprocessor from GitHub. And what you see in here, you got 3 files. You got the preprocessor itself, some README, and a folder called tests. So let's go in that folder. Let's see what's in there. So I can more or less just build the test by running this script. But let's quickly have a look at how they look like. These tests, they're in the source folder. Here it is. Here is, here are the tests. So this is more or less like what you've seen on the slide as well. So here it's defining an array and it's creating data, sinus data here with some JavaScript encode using the .byte. There's another example doing the same for the cosinus function. And at the end, the example you already saw here for getting the, loading the picture. And in this main file, main function, I don't actually use it, but I just want to see if it can compile with this test. So let's run the test and let's see what's the resulting code. So if I run it, and if I do a press -x, maybe you know this or maybe not, but it will show what is the commands inside of the script. So I'm running this and okay, so a bunch of output. Let me show you quickly what it does. This is the first command. Here it's running the preprocessor with the path to the compiler, with the path to the folder for the temporary files. And here's all of the other parameters. And here's then the list of files it's compiling. It's only 1 file now, but it could be many. When you run it, it shows you more or less, it's Oscar 64 P. This is the version. Okay, it likes Commodore. It tells you where it puts the files, all of the files you specified, the compiler path, etc. So then it runs and it goes through all of the files, and here's only one. So file 0 of 1, which is this one. And each time it finds these directives for this preprocessor, it will create a line looking like this, executing so many lines of Node.js or JavaScript code to generate C code. And it's in this particular place in the source file where you can find this. And the resulting of this was 256 bytes of data, which is actually exactly what we saw before. We look on the source here, and then we look on how many bytes of data we wanted is 256. So that seems to match. And let's look at the output then. So in the build folder, I got the gen folder. I generate the code. Okay, this is how it looks like. It uses pragmas everywhere to refer back if there's an error in the generated code to which it was the file and which is the line number. And you see it doesn't just show the file name, it shows both file names. So the generated one and the original one. This is original C code. This is generated C code. Then there's another pragma, generated C code, etc., etc. And you see there's lots of numbers there. And here where the character set is imported, you may remember that I mentioned it was using the H byte operator. So these are in hex. It doesn't need to be, but you can choose this if you want or if you don't want. Okay, let me quit this and show you. Right. So this is then the game I am having been converting. And let me show you how I use it in practice. Let's see if I find something here. So one of the things really that I was also using it for, besides graphics data, also sound data, where it was pretty handy for. Well, as you see, I need to define this function. So this is where the example comes from. Then let's see if I can find. Right, okay, so here I find the first example to make the sound if the player is dying. So a whole bunch of code, and here it outputs the waveform, some information on event, the frequency, and the pulse width. Both outputting bytes, but it can also output words. So these are values that can be higher than 255. Okay. So what is it left to show then? Right, okay, so where can you get it? Well, you can find it on my GitHub account. It's also in the invitation of this this meeting. And here you can just go to download the zip, and you just need to unzip the folder anywhere really on your disk. The scripts are made for Linux, but you can surely convert them to Windows if you want. And this is not the Oscar64 pp.js script. This is working on all platforms. It's the test scripts that I'm talking about. You have some dependencies. You need to have Node.js. You need to have PNG.js. If you go into the README here, it will tell you how to install it. It's just typing one line of text into the terminal. And of course, you need the Oscar64 compiler. And well, then the question sometimes comes up, at least I see it very often in Twitter and on Discord and everywhere. I mean, is using a C compiler for programming a C64 any good? Well, I can't answer that for you. I guess there's a lot of people that like it. There's even more people that like to compile, make projects in assembly for the C64. For me, there are some pros. It's easier than assembly, but that's just because it's easier for me. Maybe someone who's a wizard in assembly thinks otherwise. I was more familiar with it, and it actually does work to create a C64 program with it with a reasonable effort. That was a big plus for me. And there is reasonable support for the hardware. So this is really, more or less why I went the C road. And then in the end, I stumbled on Oscar64 and why I created the Oscar64 preprocessor. So yeah, that's all more or less I want to say about this. If you have any questions, you can ask now or just contact me later if you want. And thank you for listening.
Well, thank you. Thanks a lot, Dusty. I have again this.
Okay.
I have a couple of questions actually, or maybe just no, not a couple, just one. I see this Oscar 64 the compiler itself is not open source. It's quite recent, I think. Or at least I see that it's quite a practical project because I see now on the page from Mortal Kombat they even have commits from today, right? So why not getting in touch with them and trying to include these functionalities directly in the original Oscar 64?
Yeah, I may actually do that at some point, may I offer, but I'm not sure if I'm really going to be any help. I mean, making a compiler is much more complicated than making a preprocessor. I mean, so this is it. I mean, I would love to try to help, but I have to see how that one goes.
Okay. Good, thanks. I don't know if there are other questions. Looking at the chat, I don't see.
Yeah, I just wanted to say that I really found it super interesting because I kind of went the same way of being a JavaScript developer myself, moving to writing C code for the Commodore Amiga. And I had the same exact thought, like, why is it so difficult to include binary input data into a C program? I just want to include the C PNG file and we're done with it. So no idea that there were other people doing similar things. So it's super interesting to see. Thanks.
Yeah, I mean, you're happy to copy and hack it and make it your own thing if you want and do something like that. But yeah, I mean, for me, it was a sort of extension of something I've been doing on the Amiga. Like, it feels like 1,000 years ago. But so there was also coding on C. And I also wanted to expand the language a little bit because I wanted to do a few things that it didn't do out of the box. So I created also a preprocessor there. And when I saw this, I was thinking, well, let's make another one. Okay. Well, thank you for the question.
Good. Many thanks, Desi. I will stop the recording now. And last but not least, going now to Switzerland, we have David Given, who will talk about the CPM65. Then, if you're ready, David, and still awakened.
How is my audibility?
Oh, perfect. With the professional microphone there, can be only super nice.
All right.
Let me just start the recording.
Let me find the share screen button.
Okay. Yes, you have it, I guess. Good. No.
So.
Recording has started. The floor is yours, David. Thank you.
Okay. I have to say, following up GeckOS and OS 128 with CPM is a bit cruel. Luckily, CPM takes pride in having no features whatsoever. Yes, my name is David Given. I have a small YouTube channel and a website, and I have ported the venerable operating system CPM to the 6502. CPM, if you don't know, is a very, very old disk-based operating system by Digital Research dating back to the early 70s. It targets the 8080 and later, of course, the Z80, but did get ported to a number of other systems, including the 8086 and 68000, although it never really took off there at all. It is so old that some of the I/O calls in it refer to teletypes and punch tape readers. In terms of what it is good at, it has almost no requirements. It will run on nearly anything provided it's got more than about 16K of RAM and, of course, is a 8080. It is so minimal, it doesn't even use interrupts. I mentioned earlier it has no features. It has, I think, 3. The first is the file system, which is extremely good. It is a robust, fast file system supporting things like holes, arbitrary fragmentation, true random access, etc., etc. CP/M programs can have an arbitrary number of files open at once. It has a very simple shell allowing you to load programs, and it has a batch system that allows you to run scripts from text files. The total kernel size, or in CP/M terminology, the BDOS, is 3.5K of portable code. When you buy CP/M from Digital Research, you actually get a relocatable file containing the kernel. Another 2K is for the shell called the CCP. You get that as well. And the only thing you need to make them go is a BIOS that provides the low-level system calls to actually interface to the hardware. So CP/M65, the thing I've done, is a rewrite from scratch in 6502 machine code. And I need to point out this will not let you run 8080 programs. I have had a number of odd comments. It is very deliberately a almost direct conversion from the original. I use the original source code, which is now open source, as a reference for doing the port. By the way, if you're interested, the whole process was recorded in great length and is on my YouTube channel if for some reason you're having trouble getting to sleep. I did make some changes for places that the different hardware requirements required it. And also because life is too short, it is all cross-compiled from a PC. This allows me to integrate in with the LLVM MOS C compiler for writing programs for CP/M65 in C. This is useful for tooling. And I believe I have a good coverage on platforms it runs on. That is, reading the list off the screen, the Commodore PET. This is the 4032, 40 something else. No, sorry, the 4032, the 8032, and the 8096 with the extra memory. The VIC-20, although a fully expanded VIC-20, the C64, Commander X16, Apple II, Auric Atmos, BBC Micro, and the Atari 800, which was mostly donated by somebody else, very kindly. This is the main question that comes up. And apart from the obvious answer, which is, why not? I actually had, as one of my other projects, a compiler for a programming language called Calgol. This is designed to be a self-hosting compiler for 8-bit systems. So it doesn't cross-compile. Well, you can cross-compile, but you can compile programs on the 8-bit systems themselves. And this works on the 8080, Z80, 6502, and a bunch of other systems. I wanted to be able to run the compiler on the Commodore 64. Unfortunately, the compiler is big enough that there's actually several programs that get run one after the other. And the C64 doesn't really have any functionality for doing that, as the user interface shell is basic. And of course, once you've loaded a machine code program, loading another one is tricky. I did write a very simple shell for doing this, but then I've realized that the C64 has this unique relationship to random access with files. I did look into using .rel files, but it turns out that hardly any emulators actually support them. So I needed a method to load programs and a proper file system, and one thing led to another, and I ended up doing this. I still haven't got round to actually porting Calgol to it. So there are a few issues. The main one is that original CP/M was designed to run on very homogeneous hardware. The hardware was designed for CP/M, which was basically a huge box of RAM with nothing in it. A bootstrap ROM would load the BIOS into memory. That would load the BDOS and CCP, and then the bootstrap ROM would page itself out, and you just ended up with memory. Programs would load at a fixed address, which meant that loading programs was very easy because it's just a memory image. You load it from disk and plonk it down in RAM, and you're ready to go. There was a 0 page, so it was used for something different than the 6502. Unfortunately, 6502-based systems are somewhat disparate because they weren't designed for this. And the user RAM is all over the place. I have memory maps for the PET VIC-20 and C64 here with the BBC B to tell you just how much worse it could be. These are not to scale, by the way. So a 32K PET has one big chunk of RAM. A fully expanded VIC-20 has 3 chunks of RAM. A C64, I'll talk about the C64 port and a little bit more in a bit. This has got BASIC mapped out, but the kernel is still present. This has 1 chunk of memory. The BBC Micro, the screen is a variable size, and the OS reserved space here is a variable size. So you don't actually know where the main user RAM starts or ends. Luckily, there is a 1K chunk of RAM which is usable. So the solution is, of course, you put things in different places. This requires a relocatable binary loader. As with all the other operating systems we've heard about today, you have to do relocatable binaries. The 3 components of the operating system, the BIOS, the BDOS, and the CCP, can get put basically anywhere. So I can pack things into various spaces, like here on the VIC-20, the BIOS goes in the bottom chunk, the BDOS and the CCP go in the top chunk with some spare. So the main user program, which has to be contiguous, gets all the available space here. On the BBC Micro, the BIOS goes into that 1K chunk. The BDOS and the CCP then get loaded dynamically just below the screen, and you get a tiny sliver of RAM available for your actual program. Oh yes, and just like with GeckOS, we have to relocate 0 page references as well, because reasons. Moving on, there's a completely unrelated thing which is so beautifully evil that I have to talk about it, which is on the Commodore platforms, because you have to boot the system by loading a file from a Commodore format disk. But CP/M has its own file system, so you have to run the system from a CP/M format disk. Luckily, the 2 file systems put their metadata in different places. So I can make a magic hybrid file system that is both a valid CBM file system with the BAM and directory and the files you need to boot it in the middle of the disk, and is also a valid CP/M file system with the CP/M directory at the beginning of the disk, which is neat and also makes testing very convenient. So, some limitations. On a number of these platforms, the ROM vectors that the CPU uses for doing stuff like interrupts are in ROM, which means they're not really easy to change. On platforms like the Commodore PET, they actually get indirected through some memory that I would really like to use for something else. I did think about putting jump pads at the right locations, but it turns out that CP/M doesn't need any interrupts. It will run quite happily with interrupts turned off completely. It doesn't even have a timer. So that is very neatly solves the problem. And of course, when talking about disparate systems like the Apple II and the Commodore ecosystem, you're not going to be able to use floppy disks from one in the other. I mean, the binaries are all portable, but it'd be really nice to come up with a really clever way to use the same disk in a bunch of different systems, but I don't think I'm going to get there. And of course, the biggest problem is that nearly all the software for CPM65 I have written. So there are a few things that need to be done. And if anyone wants to help, that would be awesome. The C64 and the VIC-20 ports aren't great. 300 bytes per second is not brilliant for a disk-based operating system. The C64 version, I didn't put a lot of effort into. It just uses the kernel for nearly everything, which is why I haven't mapped out the ROM here. If I were to go bare metal, I would replace this with RAM. I would get to use the reserved space down here, and it would be, you get a lot more space available. But I haven't, because I haven't bothered. Both platforms need fast loader integration. Likewise, I never bothered to finish the TTY emulation on the C64. So bytes just get sent directly to the kernel after remapping from ASCII to PETSCII. And one thing that would be really interesting to do is to try running CPM65 binaries on other operating systems. There is no technical reason why you couldn't run these binaries on, OS 128 or GeckOS. You would need a small system call translator for doing the file system things, reading and writing characters, but that should be fairly straightforward, as CPM65 binaries are relocatable. You just have a binary loader that loads as a program and then loads and runs a CPM65 binary. It is, of course, all open source. It is a combination of BSD and GPL licensed because it borrows a lot of bits from other projects. Getting it onto a Commodore 64 disk may be tricky. So just let me quickly plug Flux Engine, which is another project of mine, which is a hardware solution for allowing you to write, for example, Commodore disks using a normal PC drive. I have used this to generate a CPM65 disk and tried it on a real C64, and it worked. That was awesome. So let me quickly move on to the demo. Can people see 4 emulators?
I can see that.
Excellent. I've got here 4 emulators. C64, VIC-20. This is a PET 4032, I think. And down here is, of course, the BBC Micro for comparison purposes. I do have an 8096 port, but it runs in 80 column mode. And I thought it would be, I thought the 40 column version would be more readable. So I will just start those booting because it takes ages. Yeah. So here on the PET, if I look at the directory, so the CBM file system has got one file on it, and you notice there are no blocks free. All blocks on the file system are marked as in use. And that boots, and that boots. So the PET has started up reasonably quickly. Oh, these have both caught up, which is nice. So the free command tells you how much memory you have free. There are 2 memory pools supported for system things and user memory. So this is telling me that the main user memory has got these bytes of 0 page available and these pages of user memory available. So that's from 1A00 to 8000. On the C64, you get more, 1F to D1000. The VIC-20, slightly less, 2000 to 8000. And this is a BBC Micro with coprocessor, so you get masses of memory. What do we have? We have a small set of software, including an assembler. Let me just start assembling the test program there. And there. And there. We have QE, which is a VI-like text editor that I wrote. And it will load. There we go. Allowing you to edit the file. Apparently I didn't implement this change word functionality. So that will write back. And you'll notice that the BBC Micro has finished assembling it, while the C64 has only just finished loading the assembler. We can assemble the file ourselves on the PET, which should be relatively quick. Still not quick enough, so I don't have any dead air, but there we go. And we should be able to run it. You notice the VIC-20 showing 40 slightly crude characters wide. It is using one of the standard VIC-20 tricks for doing 40 column with 4 pixel wide fonts in pseudo graphics mode. And oh yeah, there we go. And we should be able to verify that these are in fact the same binary by dumping them. And once those finally load, you should be able, there we go, to check that all these numbers are in fact the same, apart from, of course, the modified string in this one. The assembler is fairly crude. It's written in C by me. It's a simple in-memory assembler with a few bits of extra functionality for very basic structured programming, because trying to manually manage local labels is not really fun. So here is a simple program that uses some CPM entry points. Everything in CPM is routed through this BDOS function, which is patched. It's at the beginning of the binary. It's patched when the program is loaded to point at the BDOS. So here is a system call that fetches the BIOS entry point. Then we look up the screen device driver. Then we call the opcode, the operation on the screen device driver to clear the screen. Only the PET and the BBC Micro have screen drivers. I didn't bother with the other two. This is a feature that traditional CPM doesn't have, by the way. What have we got? Oh, yes. And of course, you need a BASIC. The only open source 602 BASIC I could find was Altera BASIC from the Atari 800 community. So I have ported that to CPM 65, which was more work that should have been. It's not a very standard basic, so it doesn't like next on its own. You have to put next I in, and its string handling is a bit weird, but it does work. And that also runs on the BBC Micro. And it should run on the VIC-20 eventually, but it won't run on the C64 because the C64 doesn't quite have enough zero page available. There we go. Altera Basic uses quite a lot of zero page, and because the C64 port is working through the kernel, there's just not very much available. So it's loaded on the BBC Micro. The BBC Micro here is running on a 3 megahertz 6002, so it's dramatically faster than the other platforms. Here we have it on the VIC-20. The VIC-20 actually scrolls 2 lines at a time because, you know, that is how the pseudo text mode works. And in fact, the C64 version and the VIC-20 version, because they're both working through a 1541 drive, these disks are interoperable. You cannot boot one on the other because the kernel itself is, of course, has to be specific for each platform, but you can load each other's binaries easily. And I know that with appropriate hacking, it is possible to use 1541 disks on a PET. I just don't know how to do that. So yes, it should be possible to compile stuff on the VIC-20 and transfer the binary to any other C64, C65 platform, and it should work. Okay, that is the demo. Questions?
I see plenty of questions and comments. I think, Andre, you're the one probably having the most of these. Do you want to start?
Yeah, I can. Thank you. Excellent work. I really like it. And it gives me the hint to demo GeckOS on the pad the next time because it's much snappier, of course. The main question is, what technique are you using to do the relocate on binaries?
I wrote my own relocator. If you look at the hex dump here, just trying to remember how the file format works.
Yeah, I noticed it's not an 065 file.
No, it's not. 2 main reasons for that. The first of which is I didn't know 065 existed until after I had done it. But also I wanted the... Okay, that didn't contain the information I wanted. But also I wanted the relocator to be as small as humanly possible. So it is currently 99 bytes. It has to live in the BIOS because the BIOS uses it to load the CCP and the BDOS. In fact, the way it works is there is a small header of 7 bytes. That A9 here is the start of the executable program. That 4C00 is the jump to the BDOS that gets patched in. And these 4 bytes contain the amount of zero page required, the amount of TPA required, and the offset into the file of the relocation table. So that's byte 21 hex, which is here. So this is the relocation data for this very small program.
Okay, nice. So if you're running
you had another question, Andre, on these interrupts and the keyboard, I think, or was this answer in the meantime maybe?
So but now maybe you can explain it. I think I got it now. If you don't have interrupts, and you scan the keyboard, and probably the shell just if the program calls the get me a character.
Yeah, it's terrible, but it's easy.
Yeah.
Unless the computer is actually waiting for a key presses are not acknowledged.
Thank you.
One day.
Okay. Any other questions?
I can't see the chat, by the way.
No, I'm looking at the chat, but actually it's it's also mixing. Yeah, the Zoom chat is not that good because it's mixing up when you have private messages as well. So that's why I'm asking if anybody has any questions still open, please just unmute yourself and ask the question directly. Okay. If not, then I will. I think we can just close the recording. I would say many thanks, David.
No trouble.
Recordings. Good. Yeah. So that leads us to the end of this meeting. Yeah, slightly delayed. A bit more than slightly delayed. I'll share my screen again. So the next meeting is then in March 2024. Of course, so we will accept the proposals of talks as of today. You can already send them. Many thanks again for all the attendees. Also for people watching the event from the Facebook page, and of course definitely to all the speakers. As you know, as I always say, if there are no speakers, there is no event neither. I think the popularity of the event has also went through us on the YouTube page, thanks to the very high quality content that you guys are providing. So many thanks again. And yeah, that's it. And I wish you all a very good evening. And let's close now. I see something still in the chat. Sorry, what is this?
Thank you for your organization, and happy holidays, everyone.
You're more than welcome. I see a quick message from David here. If anyone wants to contribute a C64 fast loader or V20, I'd love one. Message noted, I guess. Good.
I
Many
will
thanks.
at least make the Jiffy DOS source that I have available again on the Facebook page.
Perfect. Yeah, if you can
Is
share
that the original Jiffy DOS, or is it a rewrite?
No, it is a re-implementation by H2 Obsession, a page that no longer exists. And it's based on a project called VDOS.
Does it have an actual license attached to it, or is it like?
It does have an actual license attached to it. I have to check. My memory says that it is actually GPL.
Excellent.
If you can provide the link, I'm not on Facebook, so maybe or Sebastian can send it by mail or something.
Yeah. The problem is that the site that used to host it is no longer available, so I will make it available then on my own website.
Okay, just let us know, because I'm looking for that stuff as well.
Okay.
Great.
Thank you for the opportunity.
Many thanks again to all of you. I will close the call now. Have a good evening. Yeah, speak next time. Bye-bye.